So, yesterday in lecture I didn't quite get through to the part that I wanted to, so I'm going to talk about that briefly today. But we're going to do a 1 to 20 dilution, okay, with the leukotic solution, which is the blue, okay. Then we're going to do a 1 to 50 with 2% glacial acetic acid. The way I did my dilution is 10 microliters of whole blood to 500 microliters of glacial acetic acid, okay? That's my ratio, 10 to 500, but that's not my dilution. If you want to figure out your dilution, you add those two together, okay? So it'd be 510 microliters and divide by the amount of specimen you used. And that's how I got my 1 to 50 dilution, okay? So 510 divided by 10 gives me a 1 to 50 dilution. Okay? It's just like if you take 1 part blood and 1 part dilution or diluent, you have a 1 to 1 ratio, right? But what's your dilution? 1 to 2. Okay. So that's how you figure out dilutions. Okay. Our universal formula that we talked about yesterday, we're going to figure out the total number of cells. And how many cells do we want to try and count? At least 100, okay? Divided by the number of squares. Today we're going to be using the large squares. So there's 9 large squares on our Hemacytometer grid, okay? And I'm typically going to count the 4 outer squares first. If I get to 100, say, in this square, do I have to finish counting the whole entire square? Yeah, you have to finish counting the whole entire square, okay? So you can't just stop at 100, because you need to factor in the number of squares, okay? So we've got the number of cells divided by the number of squares times our dilution factor. So in this case, what are we going to be working with? Either 20 or 50. So we're going to multiply by 20 or by 50, depending on the dilution that you're using, right? Okay. Our volume correction factor, I touched on that briefly yesterday. One of these squares has a volume of 0.1 microliter or 0.1 millimeters cubed, okay? That divided by the whole volume gives us a volume correction factor of 10. So I'm just taking 0.1, dividing it into 1, and that gives me my 10. Okay? So I'm compensating for not counting the whole entire square if I just count 1 square by multiplying my calculation by 10. Okay? So the volume correction factor that we're going to use today is going to be 10. Okay? If we use the smaller center square that's divided into 25 smaller squares, does anybody remember the volume of one of those squares?
1, 2, 3.
Yeah, the volume is 0.004 microliters. And if you divide that into 1, that gives you a factor of 250. So one of these little squares is 1/250th of the total squares. So we're not going to use that today, but we may use it Thursday. So those are the numbers you have to remember. And now we have to figure out what our average number of cells per square is. So we're going to count our cells, at least to 100, divide by the number of squares, and that's our average number of cells per square. Average cells per square. Okay, shall we do it?